This design is split in 3 parts, and each part is given to the best candidate to process it. First, the user interface part is done in managed code under the Microsoft Net Macro Framework with its rich Windows presentation foundation. Secondly, the data processing part is done in native code under FreeRTOS. And third, all hardware-related interfaces are done with the FPGA. The external hardware up to the SPDIF output connectors is limited to the bare minimum. Not shown here, but there is a simple resistor divider for the touch panel, a low jitter oscillator for the SPDIF time base, and 2 simple voltage translators to output SPDIF. The user interface was quickly written in C# under Visual Studio, and it's pretty crude. Like there is no optimization like caching, and every time something needs to be updated on the display, the full screen is completely regenerated, including reading a bitmap images from the SD card. But the Zinc is pretty fast, so I didn't bother for now. There are 3 types of screens: CD folder 3x3, CD list 4x4, and the playing CD. This is a coding sequence for interprocessor communication. The function slave CD command passes the CD name and the track number from NetMF to FreeRTOS. Parameters are serialized, and a software interrupt is generated to CPU1. On the other side, when a CD is playing, a software interrupt is generated every 1.5 seconds from FreeRTOS to NetMF in order to update the playing position on the display. I have described in a previous video both function slave and interrupt slave. The play loop sequence on the native side. Stereo audio samples are read in chunks of 64K. For convolution, a FFT is done to get to the frequency domain, apply the room correction, and FFT again to get back to the time domain. A delay will compensate different speakers' propagation time. And finally, the crossover filters, which actually should be done in the FPGA fabric instead. Here is my room measurement, together with the room correction impulse response calculated with Dennis Brajan's fantastic DRC module. And in between is a new room measurement after correction. This is a FPGA design with SPDIF, TFT, and touch panel interfaces. Data is transferred with DMA to the TFT controller, configured as 8-bit parallel mode, and it takes about 3 milliseconds to transfer the complete 320 by 240 16-bit pixel to the display. So this is really fast. This IP decodes the command from the CPU and generates the correct sequence to the TFT controller. Regarding the touch panel, the Xilinx ADC is the main component here, and this IP will do the control and filtering so that only relevant data is put into the FIFO and an interrupt is being generated to NetMF. For the SPDIF interface, there are two block RAM FIFOs here and here, while one is being outputted to the 2 SPDIF connectors. The other one is being filled up by FreeRTOS, by DMA, of course. The Zinc is fast, very fast. I use the pi-digit calculation method to compare the speed of interpreted code running first on the STM Discovery 4 kit with a 168 MHz clock, and then on the Xilinx Zinc with a 667 MHz clock. for both. Tanning Clear is built with the exact same GCC version, respectively for the Cortex-M4 and the Cortex-A9. So the parallel, TFT display, resistor divider for the touch panel, SPDIF time base, voltage transistor for SPDIF, low pass, high pass SPDIF outputs, JTAG connector, and a serial port to NetMF Visual Studio. I intend to make a PCB with a TFT, so nice footprint. As I said during the presentation, the user interface is 100% managed code, pure NetMF stuff, and the screen is completely regenerated on each update. Here there are 16 bitmap image files read from the SD card each time, and the complete screen is dumped to the TFT graphic memory in about 3 milliseconds. There is only one SD card, so both CPUs compete for it. FreeRTOS when playing the WAV file, NetMF when reading bitmap images.
Hard times behind, hard times ahead. It's a miracle we still living. It's a wonder we ain't dead. I read it in the paper, I heard it in the news. This old world's in trouble. People, we're all chased by the blue, and the planet still keeps turning, draws a circle around the sun. Seasons come and the seasons go. What's been done can't be made undone.